Alright, good morning everybody. My name is Isaac from SISAKEST Engineering Services. So this morning I will be demonstrating some things for us on how to use ultrasonic sensor for measuring distance between one particular locations to the next obstacle. Then this is Arduino. I will be using Arduino to do the job. This is my breadboard with some jumper wire. The aim of this class is to be able to use this distance that the ultrasonic sensor measure this morning to measure the volume of water in a tank and give the user the current water level, the percentage at which you want the pump to come on and the pump to go on. So the design is that we have a ball in this house that we have to go there to on and off it. So what we want to do is to come up with an automation system that can actually do that without human intervention. So we'll be using ultrasonic sensors to do that. Good morning. Alright. So this Arduino is called Arduino Uno, and this is ultrasonic sensors. Okay, let's start. Ultrasonic sensors has 4 pin. The one with me here has 4 pin, and it's HCSR04. It has 4 pin. The VCC, which is the positive, the trigger, the echo, and the ground, which is the negative. Okay, how does it work? If you take an ultrasonic sensor like this, and this particular part called the trigger, the transmitter send out a wave of sound. As it send out the waves of sound, the wave missed an obstacle and return back, and the echo the receiver receive the echo. And that timing difference between when the trigger send out that particular signal and when the receiver receive it is what we need to fit into the equations of velocity equals to distance over time. So to obtain distance will be velocity multiplied by time. But in this case, because your ultrasonic sensor have to send a signal to meet the obstacles and come back, so it will cover twice the distance of the obstacle. So we'll be dividing that value by 2. We'll be putting all these things into programs that you will see in some minutes time now. So on my screen now you will see no IDE is open. So what you need to do is to first of all do variable declarations. What is variable declaration? You are just telling the microcontroller to create some memory space where you want to store some data. So one of the important data here is int trigger pin. Intrigue pin. So this talks about, let me use 7, then semicolon, then you do int echo pin equals 8 semicolon. What this simply means is that when we are connecting our ultrasonic sensor, will connect trigger pin to pin 7 of the Arduino, will connect echo pin to pin 8 on the Arduino board. That's what that simply means. So we'll be in need of another variable called distance, so which is the distance between the ultrasonic sensors and the obstacles. So what we are saying is that anywhere the ultrasonic sensor moves, the obstacle is seized along that particular location. That is exact distance it's going to give to us. So if I place my ultrasonic sensor like this, it's going to give me the distance between here and here based on this. So the reason we want to confirm our answers with a meter, with a tape and a vernier indicator, vernier caliper. Alright. So I enter my setup code now. So in setup I will say pin mode trigger pin. So trigger pin is expected to send out a sine wave. It's expected to send out a sine wave. So trigger pin automatically becomes an output. Then similarly, or in contrast, echo pin will be input, because we are expecting to receive a input signal from echo. Alright, so the first thing we'll be doing in void loop the code that actually runs and give us the distance. Okay, still on my setup, let me do one more thing. Because this distance now, we need to be able to see this distance, so I will be using my serial monitor to do it for the very first time before we transfer it to an LCD code. So serial begin at 9600 baud rate. That's the communication between the Arduino and the laptop. So digital write whatsoever in trigger pin. Write whatsoever in trigger pin to low. Why are we doing this particular operation? We are doing it because at the beginning of this program we want to ensure that the trigger pin is low. So we wait for some microseconds, delay in microseconds. We are waiting for about 5 microseconds. So what we'll do is that we'll try and on our trigger pin. So at this level, what we are doing is that we are actually sending some pulse of signals through the transmitter, through the trigger pin, so that the trigger pin activates the transmitter. You can see the T, the transmitter, and the receiver here. So the trigger pin works directly with this guy to send out a particular wave. So we wait also. We keep the trigger pin on for about 2 microseconds. Then later in the day, we off it on trigger. So let me declare another variable called, so I'll be using long because I'm expecting a bigger value, called duration. This duration is the exact time it takes for the wave sent by transmitter to goes out, hit an obstacles and come back. So that's the total time it takes for that. Then so we say duration equal pulse in. I want to explain this function. Pulse in of echo, comma I. So pulse in is a function on Arduino. What it does is that it takes the time taken between a successive signals to an echo. So that time taken is stored in a place called duration. Then if I'm to obtain my distance from the previous explanations that we did before, that distance will now be equal to distance equals to velocity times time divided by 2 now. So what's the velocity? The speed of sand in air is 346 multiplied by velocity times duration divided by 2000. What that 2000, the 1000 factor behind the 2 is that we are trying to convert from meter per second to millimeter. So I want my answers to be in millimeter. So it will be like serial dot print into brackets distance and also serial dot print new line whatsoever is in distance semicolon. So after you are doing this, you wait for 1 second, then the process continues. So I'll save this video now. I'll save this particular program now. Call distance measure Alright, so you have to get your Arduino board. You have to get your Arduino board. So you have to get your Arduino board and a USB port. So for this particular program, I'm using Arduino Uno. So you plug it at your USB. You can hear the sound from the system that the Arduino board is connected now. Then you go to tools, you go to board, you select the right board, then you go to port, then you select the right port. So the next thing you have to do is to upload the program. So currently I'm uploading the program now. So I want to do the connections now. So you have the VCC, the trigger, the echo, and the ground. So green is the VCC, so we take the green to be ground 5 volts. So from our program we say the trigger pin, which is the next one, blue, is going to pin 7 from our program, and the echo pin is going to pin 8. This is pin 8 on Arduino board, this pin 7, then the ground goes to ground. So what we'll be doing now is to open our serial monitor on our laptop now. So currently now we are measuring a distance of 270, 391. So what we'll be doing, just to confirm this value, is that we'll be measuring. So it's giving me 104, 102. Don't mind the little disparity in the number. It's as a result of my hands is shaking. So I have 110. So it's just a process of confirmation. How will I do this? So I place this at an average of 100. As you can see, this should be 100. You see, I don't know. So we place this at an average of 100, and you can see on your screen that that's what is there now. What's our aim? Our aim is not actually to just obtain this distance. What do we want to use the distance to do? We want to use the distance to be able to verify the level of water in a given time. So I have a small experiment in here to demonstrate how this works. So assuming that this is your overhead tank. So you find a particular place and you place your device, ultrasonic sensors, on it like this. So observe what will happen to the level of your water inside the tank as you keep adding more water. You can see that means as the wave, the number getting decreased as the water comes up. So we can use this particular variable to do a lot of work in controlling the water pump, when to start and when to stop. See, as the water is very close to the level of ultrasonic now, about 4 cm to the level of ultrasonic, about 4 cm as you can see. Alright, so what did I need to know? So if I want to use this value for a particular work now, what I need to know is that I need to know the height of my tank. So I will have, so this distance is what we call the current height. So what you want to do when you want to program such a particular device, what you do is that you look at the value of your tank, then you can use that to confirm the quantity of water, the height of your tank, then you can use that to do the variations. Actually, only this particular data can control your pump on and off if you really don't want to do a very good job. But what we want to do in this particular video is to do extremely nice job. Don't mind the ultrasonic sensor, it's giving me the distance between this particular surface to the ceiling of the building. Alright, so what we want to do is that we want to be able to give our user the value of water in his tank at every point in time, especially in percentage. So how we go about this? So you go to your program again. So we are introducing another value called, so this is a constant integer called the height. Which height? The height of the tank. So if you have a physical tank, all you have to do is, so I'll be using this as my typical physical tank for this whole operations. So the height of my tank is 170, so that's 170 mm. So constant int means that the value is not going to change in the program. So anytime you get to another particular situations, all you have to do is to introduce another, change this value, and the whole program knows how to calculate itself to the level. So the first thing we want to try and do is to evaluate the volume of water in your tank. So how are we going to do that? We'll look at the whatsoever the current level the ultrasonic sensor is given to us minus the height, then we'll call that the level, then we'll use that to calculate the volume. From that, there are two ways. If you really want to get the volume in meter cube, in centimeter cube, or as the case may be, then you have to come and obtain the diameter of your tank. But for this particular programs, we are not going to be doing the volume. What we'll be doing is that we'll be relating it in percentage, the percentage of what the water is to the total tank. That's exactly what we'll be doing in the program. So we'll call that height. Then let's introduce another variable called int. So that variable will be called current level, current percent. So we are doing it in percentage, so current percent. So that will tell us the particular percentage of water in our tank. So you go to your program, the distance you obtained previously, you say level now, current level. Okay, let me introduce another program, a variable called level. Int level equal to height minus the distance. Height, so whatsoever the total height is, so I want to minus the current level, the current distance. You know, if I put my ultrasonic, let me just do it physically for us so that we can understand what really happens. Let's say the level of water is here now, inside the tank. Then this is the height of the tank. So this is the distance called level. So the easiest way to get it is that ultrasonic sensor gave me this distance. So I will now subtract this distance from the total distance. Then that's what we are currently doing. So that will tell me the level of water in my tank. So why current percent? Now current percent. From a distance you can tell. Current percent will equal to whatsoever level is divided by the height, everything multiplied by 100. This will give us the percentage of water in the tank. We are not really, if you are interested in the volume, you should do by this square divided by 4 multiplied by 11. That will give you the volume of your tank. So we'll be adding a particular thing. So we'll test serial monitors to still print the value of the level of water in our tank, and we'll do the demonstration again. Distance equal this, then level equal current percent. All right, let's give ourselves what the value of level is first, then we'll talk about the percentage of how full our tank is. All right. So control copy, control V, current percent. So current percent, we do current percent, and we do current percent also. Current percent do also level here. All right, so what we'll do next is to upload the program again. So once again, let's turn the old water in our reservoir out. So we position our sensor in the right place. Then let's observe what happens on our serial monitor. So the distance is 124, the level is 46. So if we take the difference between this value and current percentage, is giving me 0. All right, let's check the program and see what that one means. Current percent is 0. Okay, so let's assume that we are increasing the level of water. So the level is increasing. So before we continue, let's remove some ambiguity. Now the value called distance, we don't need it again. So what I will do is I will just comment it out of the program so that the serial monitor doesn't show it again. So two things that is very important to us is the value of what the level is and what the level is at and what percentage is that. So let me use another particular code here. I don't know why that expression is not working. So I will map whatsoever level is, which I expect is range to be from 0 to 170 to work between 0 and 100%. So that's map function. So what we are trying to say, okay, the value of level varies between 0 and 170. So it will be a linear interpolations between 0 and 100. What we are saying is that you have two scales. So these are the two scales. One scale is in 0 to 170, for instance. Another one is between 0 to 100. So whatsoever value you have in this particular in mathematics we call it domain and subdomain. So you can actually map any function from here to here, and that's basically what happens in that particular program. So I upload the programs again and we run the experiment again. All right, let's remove the water from our tank while we are waiting for the program to. All right, so we position our sensor in place and we go back to this. So it's telling me that the level of water now, the current percent is 33, 36, and the case may be. Then so you can see the current percent rising, telling you that the percentage of water in the tank keep increasing. So the simulation here is that this is how your pump, your submersible pump inside, or this can be for liquid, a surface water pump, a centrifugal pump for your storage facility to store an oil or in your factory. This is how as the pump pumps the water and the liquid, then you can always get your current percent. So the next thing we want to be doing in this particular program this morning is that, all right, we are introducing a new solutions that doesn't really exist before. And what is that? What we are doing this particular time is we are trying to give you as a user the time you want your pump to come in and to go off. So we'll be introducing a potentiometer for you to be able to set your level at which you want your pump to start, and the pump will be stopped automatically when the level of the water gets to a particular location. So I will be writing a particular program this morning. The reason why we need to do this is that some people, they want their the minimum level of water inside their particular thing to be at a level before the pump start up. If you set the minimum level to a very high level, what will happen is that your pump will be starting and offing often, because as you use the water a little bit, the water goes down, the pump comes up. So we encourage that you set it between 20 to 25%. And let's say a particular level now, you really, if you want to have a total control, then you have to have a valve at the inlet and the outlet. This could be also a very good thing. So I'll be introducing another variable inside this program now called control. So integer control. So what does control do? Control is that particular signal that comes in, so a level at which you want your pump to start working. So control. This for a potentiometer, it has three legs: the two extreme ends and the leg of the slider. So what we are saying is that you are changing between the value of resistance as you move from these extreme positions to this other extreme position. What simply happens is that you are changing the value of resistance between these two legs and these two legs. So what we'll be doing is that the central limb now, which is the most important limb, the limbs of the slider, will be connected to analog grid AO, and the other two legs, which is the leg that carries the VCC and the ground. So let's just put that in coding now. So control. So under void loop, you go and you say control equal to analog read A0 semicolon. Now you have to say control value now. So I'm declaring another variable called control value. So control value, which will equal to map whatsoever control is, which we expect control to be between 0 and 1023, because analog read values on Arduino is 10-bit resolution. So if you do 10-bit resolution, that's 1024. So between 0 and 1023, explain why that is 1024. Then 0 and 100%. What this particular code will do is that it will be mapping every functions of this sliding between 0 to 100%. So we can use this as our control signal, when to start the pump and when the pump should remain. So we'll be introducing control value as a percentage also now. So control copy, come here. Now this time around is control control percent, then display what is in control value. So at this particular level, at this particular junction, what is in level is not important to us again. So I'll comment out what is in level. So what we'll be seeing now is control percent, and what we'll be seeing now is control percent. But we have an error here because there is no semicolon at this particular place. So we won't be looking at the level, we'll be looking at what is the current percent of water and when should we on the pump or off the pump. Alright, so again, this is my setup and serial monitor. So alright, I need to connect my potentiometer accordingly. Alright, so what you have here is ground and VCC. So there's a ground here, so there's a ground here, and there's another 5 volts. Alright, I'm looking for 5 volts. Right, there's no 5 volts here. So what we'll be doing now is that just take this to this place. Then we take a particular red wire to transmit 5 volts from the main Arduino board to this particular one. So now as I change the control percent now, let's check. Alright, this guy has not been connected to Israel. Alright, so that value that you are seeing on your screen is called floating point value. It's like that for all analog signals because they will be floating. It's called noise also. So you can see the control percent increasing as I'm changing the level. So you could decide what would be the minimum level of water in your tank when your pump should come up. So when your water gets to this level, maybe you are running an test services. So when your water gets to this level, you can also see that as at this level, the control current percent will keep increasing as if you want to reach 100% as the water comes up, while the control percent remains at its level. This is what we are saying. So the next thing we will be doing is that as the water goes out from this tank like this, as the user is using the water or you are using the liquid for your process company, so we want to be able to know that level you want your pump, maybe a submersible pump or a surface pump or a centrifugal pump, as the case may be, to come up and run. So the next thing we want to do now is that we want to be able to give that particular control for our pump. That's the next program we'll be writing. So now let's come here now. So let me define another variable called pump, and this pump will be connected via relay, and this relay will be connected to pin 5 of our Arduino. So on pin 5, this relay, this pump, this so-called pump, is expected to be what? An output, because we are going to be writing to it. So now at this junction we need to write a conditional statement called if the water level is down and is below, if the current water level now is below the set point, then the pump should come up. So we said if the current percent, let me copy this so that if the current percent is less than or equal to control value, so if peradventure we have a situation at which you set your pump to start at this particular level, that's the control point, and your water is less than this, so what we are saying is that the pump should start at that condition. So you say digital right, digital right from to I. Then S. Take a step back to see the truth around you. From a distance you can tell. That come to me low. And so the pump should be off. So but we want to tell ourselves what really happened to the pump. So one of the things we'll be doing is that it says that, so I will say that serial print to copy pump on to operate the program and demonstrate how it works. Wow. Alright, so let's go to our serial monitor and demonstrate what really happens via this code again. So I want to take a particular percentage, control percent. Alright, the whole thing is mixed up, so let me do this new line, then new line. So serial monitor. Now, control percent is showing that the water level now, the control percent is 0, which means that the only time you want this pump is when the level of water is 0. That means there is no water at all. Now, so I can increase my control percent. Let me start the other way around. So first, so I'm increasing my control percent now to 25 to 34. So I expect that at 54 the pump should run. As you can see now, the pump has come up, has started working now. So I'll try and go a little bit, so the pump is off now. So the current percent. So let's say so the pump is on now at 68%. So if I keep on giving water to the tank, so the current percent will keep increasing. See what happens. At 68, 69, the pump goes off. So you stop pumping. Now the user, the owners of the household and the chemical plant now starts sucking the whole water again. The water goes down and the pump comes up again. So once you get to the level at which you set, which you can always adjust, that's another thing we have put into this particular equations that can make you to always adjust it. All right, what is the exact time that we should stop our pump? That should be the real question. What's the exact time that we should stop our pump? The time to stop our pump is that particular time that the water level is very, very close. It's very, very close to the uppermost time. So I'm changing this particular situation that to S if the level of water now is very, very close to, if peradventure the current level, the current percent now, the current percent is greater than 95%, this is what we say that the level of water is very, very close to the sensor now, then the water should off. So there's also another scenario that we would like to paint to us as we do the part 2 of this video.
To be